Welcome to class, students. In this class we are going to discuss a looping statement for, repeat and forever. A for loop. The keyword for is used to specify this loop. The for loop contains three parts: an initial condition, a check to see if the terminating condition is true, a procedural assignment to change the value of control variable. The syntax is somewhat similar to a for loop in C, used in C programming language. The initialization condition and the incrementing procedural assignment are included in the for loop and do not need to be specified separately. The for loop cannot be used in place of while loop in all situations. Integer count. So here you can observe where for loop is used, count is initialized with 0, condition count less than 128 and count is incremented by 1. So you are displaying starting from 0 till 127, 0 to 127 count you are displaying. When count value becomes 128, this condition becomes false. So it comes out of the for loop. So here you can observe there is an initial statement or always statement in which you can use looping statement. So here within initial statement you are using a for loop. So only one statement, it is considered as one statement. So begin and end are not mandatory here. Begin and end are optional. So for loop is considered as single statement and within which you are using only one display statement, that is count equal to %d count. So if within initial, if you are using multiple statements, so you indicate start and end with begin and end. Within for loop also, if you are using multiple statements, use begin and end to mark start and end of the block for loop. For loops can also be used to initialize an array or memory as shown below. Define max states 32. So max states a global constant whose value is 32 you are defining. Next, an integer, a state which you are defining starting from 0. Max states is defined as 32. 32 minus 1 means 0 to 31. So integer state 0 to 31. One more integer I you are defining. Initial, begin. In for loop, I is initialized with 0 and here you can observe that I is incremented by 2. Means when for the first time I value is 0, next iteration I value will be 2, then again plus 2, that is 4, 6, 8, 10. So even numbers. So even locations are stored with zeros here. Till what? I less than 32. So when value becomes 32, the condition becomes false here. So 0 to 30 even locations are stored with 0. Odd locations starting from 1 till 31. Odd locations starting from 1 till 31. All the locations are filled with value 1. So you are defining a memory integer state of 31 locations. Even locations you are storing with 0, odd locations you are storing with 1 in this case. For loops are generally used when there is a fixed beginning and end to the loop. If the loop is simply looping on a certain condition, it is better to use the while loop. Repeat loop. The keyword repeat is used for this loop. The repeat construct executes the loop a fixed number of times. A repeat construct cannot be used to loop on a general logical expression. A while loop is used for that purpose. A repeat construct must contain a number which can be a constant, a variable, or a signal value. However, if the number is a variable or a signal value, it is evaluated only when the loop starts and not during the loop execution. Integer count, increment and display count from 0 to 127. So count initialized to 0 within initial statement. So multiple statement begin and end to indicate start and end of the initial statement, and this begin and end to indicate start and end of repeat statement. In repeat you are using two statements, so begin and end becomes compulsory. Count is initialized with 0, and here count value you are displaying starting from count value starting from 0 till 127. So 0 to 127 means this particular repeat loop will repeat for 128 times. So it will display 0 to 127. 0 to 127 means including 0, 128 times this particular loop is executed. Data buffer module example. After it receives a data start signal, reads data for next 8 cycles. Module data buffer, data start, data clock. Parameter cycles 8. So a cycles parameter you are initializing with 8. It is like defining constant. In Verilog, cycles will have value 8. Input data start, data size is 16 bit, 15 down to 0. Input clock, register, here you are defining 15 down to 0, buffer 0 to 7. Integer I always at passage of the clock begin if data start. So within always statement on rising edge of the clock you are checking data start signal. If this data start signal is 1, then I is initialized to 0. Repeat for 8 cycles. Repeat for 8 cycles and store buffer I. It is as good as you are defining. You are defining an array of the location 0 to 7, that is 8 locations. Each location can contain a 16 bit data. So buffer 0 to 7 data size is 16 bit. Each time you are storing 16 bit data in buffer in location starting from 0 till 7. The keyword forever is used to express this loop. The loop does not contain any expression and executes forever until the $finish task is encountered. The loop is equivalent to a while loop with an expression that always evaluates to true. Example, while 1. While 1 means continuously that particular loop is executed. Condition becomes always true. So it is like infinite loop. A forever loop can be exited by the use of a disable statement. A forever loop is typically used in conjunction with timing control constructs. If timing control constructs are not used, the Verilog simulator would execute this statement infinitely without advancing simulation time, and the rest of the design would never be executed. Example 1, clock generation. Use forever loop instead of always block. Register clock initial begin. Clock is initialized with value 0. So here you are using that loop statement forever. Delay you are giving #10 clock equal to not of clock. This particular statement will generate clock with period of 20 time units. So one usage is forever statement can be used for clock generation in Verilog. We'll see synchronize two register values at every positive edge of the clock. So here what you are doing, register clock, register XY initial forever. At positive edge of the clock you are making X equal to Y. X and Y values synchronize, or you are making it same on every rising edge of the clock. Thank you students. We will continue with